Welcome back to another episode of Pollys Introduction to Computer Network. You know what? We should be... Hi, Huixing. Welcome. So let's go over the announcements first. Yeah, what's a little bit special this week's announcement is this. We do have the exam coming, guys. Yeah, the spring is coming finally. And you know what? The exam number 1 is also, right? So, hey, go on to the exam 1 channel here. Okay, clicking, and you should see a bunch of announcements. Okay, so those, each one of them, very important. Hi, Liangxin. All right, so if you're clicking, you see, wow. Okay, announcement point number 1, number 2, number 3. And there's a long explanation for point number 3 and number 4, 5, 6, 7, 8. Okay, so next Wednesday is going to be the day for the first exam. And remember, our exams are going to be operated as a Google form. And we'll be doing synchronously there, okay, online. And this is a very unusual form. So for many of you, this is not familiar, okay? And on top of that, this is an exam. You'll be anxious already. So I would really advise and highly advise that you go through the important notes here, point number 1 all the way to point number 8, okay? Be patient, go over them carefully. All right, so point number 3 is about the most important that you might want to try to do tomorrow, because we do have like a test run for the exam tomorrow. But the test run is simply that you test your camera and the laptop you prepare to use, or a computer you prepare to use, and the place you prepare to sit and take your exam. So you want a place that is somewhat nice and quiet, and you want to be a place where you can potentially say something, ask a question, okay? Because during the exam, it will take time if you type questions up. Right? It might be a little bit easier to just say it vocally. So tomorrow there's gonna be a interesting. All right. Okay. So I just discovered that my Google Meet, this allowed me from continuing a certain session. Well, we'll see how I can get it back. So tomorrow, right after the lecture, I probably will start a Google Meet session. If you click here, maybe I can click here. Click this, and tomorrow you would join, okay, and try out the computer, the camera you plan to use, and you definitely can try out the network connectivity, whether it's good enough to transmit video. And in the meantime, you can start a Google form, okay, and all Google Forms can all be found from the course exam link. Okay, so definitely do that. So this is the most important announcement Polly would like to make. Okay, exam number 1, it's coming up next Wednesday. And for today, lecture, we'll just introduce 2 more applications and the protocols designed for these applications. Number 1, FTP. This one is legacy technology because HTTP has been extended to just do exactly the same thing the FTP is doing previously. So HTTP now not only allow us to download web pages, which is a file, can also allow us to upload files. Okay, so but it helps if I talk about FTP. Okay, this is another protocol to contrast HTTP in many ways. Another application is email. Okay, this one is important. And we'll see if we have time in the end to start DNS. So let's start with the videos. Let's start with the video about FTP. Now this one is a little bit long because FTP is very straightforward. I'm just going to talk about the architecture, the message, the socket they're using in one video.
FTP, the File Transfer Protocol. This is the second application layer protocol we're learning here. So see if you can identify what is the communication model, what is the structure between all these entities involved, and what is the underlying transport layer service, and what are the message types, syntax, semantics, and how are these messages exchanged. Pay attention to these. So first of all, what is the communication model? You see here, client server. Client is always the side initiating transfer, so over here, this side. And server is always the one that's far away, it's over here. Right? So what you see here is FTP is to provide transferring of files to and from the remote host. Server here is essentially allowing the users or the client access to the hard disk here. So it's a little bit like Dropbox. So a distributed file system in a way. Good. Now, file can go this way as well as this way. So you see here, it's bi-directional. Good. The protocol is defining this RFC. Number is only 3 digits. You see that this is one of the earliest internet protocols. The server there is sitting on port 21, another well-known default port number. So whenever the client needs to initiate communication, it goes to port 21, where the FTP server will be sitting on. And by the way, 21 is also the port number that Poly confuses SSH's port number on. Right, so let's take a closer look at the message exchange. Alrighty, so FTP clients contact FTP server at port 21, this we know, and specifying TCP as the transport protocol. So FTP there uses TCP just like HTTP as the underlying transport layer service. And then the client will try to authorize itself into the server over a control connection. So what I'm depicting here is also what's going on here. The client will establish a control connection towards port 21, okay, at the remote host. So messages saying, I want to log in, here's my password, will go on this connection. After the client logs in, it's going to browse through the directories, okay, in the remote hard disk over here. So the commands changing the directories around is going to also be sent over the control connection. When the server receives a command for a file transfer, okay, so command for file transfer also travel this way as it's also a command, so it goes down the control connection. But the server now, okay, will open a TCP data connection going back this way. Okay. So that is depicted here, the data connection running on port 20. After transferring a file, the server is going to close the data connection while this one remains on. If the server needs to send another file, it would start yet another TCP connection and send the file over there. Okay. So such separation of control and data-based content on different channels, okay, in communication, we call it the out-of-band communication. If you think a little bit more, in HTTP, there are 2 messages, right? HTTP request, HTTP response. Yeah, which one is data? Which one is control? No, in fact, each of these messages are both control and data. In HTTP request, we do have comment, right? Get, post, head. But in HTTP response, we also have the status line. So these are obviously control. But in both messages, we also have the body entity. If you use a post commenting HTTP request, you might be sending also some data up to the server. And very classic web response, the entity body contains the web object. So in HTTP, communication is in-band. One word, in-band, right? Data and control messages are bundled together and going on just one connection. FTP, very weird, out-of-band communication. Another thing that FTP differs from HTTP is this. HTTP being stateless, but FTP is stateful. So FTP server here actually store information about the client's previous visit, including where this client at in the directory structure before the client logged out. Okay, so next time when the client wants to log in, the server will take him directly to whichever directory the client left. So the client can continue working on, downloading files or uploading file in that space. Similarly, if you log in as a client, you might get a message from the server saying, "Oh, you logged in previously at a certain date and certain time." So this is sometimes a nice thing to do because you might want to know if there are unauthorized login and authenticated login, meaning someone stole your password and then use it to log into the FTP server. Next are just a few examples of the messages being exchanged between the FTP client and server. So these simple comments are messages the client sent to the server. And server typically return these return codes. Right? So very much like the HTTP request, the control part sends comments and necessary information to help the comment to be executed at the server side. And then the server returns certain code, phrases, and explaining of the code and the phrases. All right, let's look at the example. Oh, and by the way, again, in FTP, messages are in ASCII text. Right? Data, however, on the data connection could be in bytecode. All right? So control connection there is always sending ASCII text messages. And control connection there is also allowing the server to send back status code. Okay? So these and these all on the control connection, only the data on the data connection. So let's begin. User, capital user, space, username. Hey, you guess, this must be a user trying to log in and providing the username. So this is a variable, so comment, argument. And this is going to be sent through the control connection to the server. Server check. If the user does have an account on the server, then this is what the server sends back. 331, username, okay. And server asks, could you send me the password? So, hey, a hacker might have figured out the username, but not necessarily the password. So, client here sends pass, again, capital, space, password, over to the server. And then the server can perform the rest of the authentication. So you see, capital, PASS, capital, USER, these are special words, okay, in the comment messages. Right? So each followed by an argument. List, this is a special comment, no argument required. What it does is to return the list of files, okay, in the remote directory. So upon receiving list at the server sends, okay, here are the files in the directory. Retrieve, RETR capital, space, file name. This is now officially to ask for a file from the server. Retrieves files. The other way around, if we want to store a file, upload the file to the server. Then store, capital, file name. Now, here are some status code and phrases the server might respond. So, 125, data connection already open, transfer starting. So this might be the server responding to a retrieve command, okay, setting up a data connection, and then next bytes are going to come. Or server might find that, hey, there's not enough socket to open, or there's not enough bandwidth can open data connection message might be going back. 452 error writing files. Oh, okay, so this is this case. If the client wants to put the file onto the server, and if there's not enough disk space, or if the client doesn't have the access right, the readable access right, the writable access right, then the client gets this message 452. Okay, so that's FTP. We see again, an application layer protocol defines communication model. Is it client server, P2P, or hybrid? An application layer protocol defines also what is the network structure. In both HTTP and FTP, it started off very simple, one client, one server. But you see earlier in HTTP, it kind of grows a little bit, having these proxy servers in the middle, helping with the transfer. In every one of these application layer protocols, we also need to define what are the messages to be exchanged and the order they exchange. So we see here examples of messages defined for a FTP and how they're exchanged, okay, in the previous slide. Okay, through the control channel, login messages, checking directory messages. So this is FTP.
All right, so it's very straightforward, just to contrast HTTP with. And now, the real applications that we're using a lot these days, email. Let's check out the communication model in email and the protocols used to support email.
2.3, emails. So this application is a little bit unusual. It's supported by not only one application layer protocol, but multiple ones. And we'll talk about it. Email application. It's got three major components. First is the user agent. This is the software running on the machine closer to the users. And mail servers are the software running on more resourceful machines farther away from the users. And among these mail servers, it runs this protocol, SMTP, the Simple Mail Transfer Protocol. These we'll also talk a bit more about. Let's start from the user agent. They're essentially the email readers. They allow us to write email, edit email, read emails. Outlook from Microsoft is one mail reader that's very well known. Thunderbird, I don't know if you know about this one. This is from Mozilla. So the company that produces also Firefox, a very well-known web browser. iPhone comes with a built-in mail reader. Google is also trying to push for a Gmail mail reader. So there are so many of these email readers these days. Now, keep in mind though, the actual emails are all stored on the servers, not on the user agent these days, right? Now the mail servers. It's got these three major components. The mailbox, which contains all the incoming messages per user. So these are the yellow boxes. When emails come in, they will be sorted out and then put into the email boxes depending on who the receivers are. Second component, the message queue. Those are the green queue over here. So messages that are going out will all be stored here temporarily and waiting for the receiving mail server to open up and then accepting the emails. So SMTP protocol there is to allow the sending server and the receiving server to communicate. Now here in particular, the sending server there is called the client of the SMTP protocol. And the receiving server is, on the other hand, the server of the SMTP protocol. So you see a little bit here. The SMTP protocol is to provide mail receiving service in a sense. So client here requesting service, server here allowing emails to come in. If you think about it more, it's got two levels of communications in the email application. So this is one between the end users and the local mail server. Okay, fetching email or pushing email out. But there's another level, which is among the mail servers. All right, so sending mail server is the client of the higher level communication. Receiving mail server is the server of the higher level communication. Then the SMTP protocol. So this is the actual application layer protocol defined to support communication in emails. So let's see, what are the underlying protocols and what is the communication model and what are the messages defined? TCP you see here. Therefore, SMTP is to support reliable email receiving service. It runs on port 25 and the transfer is direct between the sending and the receiving server. The exchange, very simplistic, three phases, handshaking, and then extra transferring of the emails, and then closing. Opening, closing, the extra transferring of the emails in between. The messages are also simplistic. They're just comments coming from the sending server, responses coming from the receiving servers. So comments in ASCII code, just like HTTP, just like FTP. Responses, status words, status phrases, status code, just like HTTP and FTP. They all run in the ASCII code. Now put all three major components together and let me illustrate with a concrete scenario. Alice here is sending an email to Bob over there. All right, so Alice will need to start the user agent first to compose an email. So in the email, it will need to specify the receiver. And then the user agent will send the email to the message queue, okay, in the local mail server. So that is step 2, emails going to the message queue. And then the client side of the SMTP, which is here, this guy is the one sending, And this Bob's mail server will be the one receiving. So this is the client of SMTP. This is the server of the SMTP. So the client side of SMTP will open up a TC connection. Once the server is allowing the connection, then the client can begin sending Alice's email. So that email will travel, and the server here of Bob's will check whether the receiver is Bob, and therefore putting the email into Bob's mailbox. So email goes to Bob's mailbox. Lastly, when Bob now joins the internet, invoke his user agent, then the agent already pre-configured to connect to the incoming mail server will then fetch the mail messages, and that's when Bob gets to read the email.
And that takes us to the quiz today. Quiz number 12. Okay, so you've seen already in the video, right, between Alice and Bob, SMTP goes all the way from the sending email sender to the local mail server, right? So that's one level of a hierarchy in email protocol. Another level, SMTP, between the servers, some of them will be the sending server, some will be the receiving server. And receiving server is in fact the server in SMTP. So the receiver's mail server there will receive emails from the sending server. And SMTP only works up to that point. Okay. Bob there, in order to fetch email, will need to use a mail access protocol. So we have not yet talked about the mail access protocol yet. But question here. Why not SMTP all the way to Bob's user agent? How come SMTP stop right there at the receiver's mail server and Bob's user agent will need to somehow log in actively from somewhere else to the receiver's mail server to fetch email? Okay, why? Okay, so let's work on that. Go to the Slack week 5 quiz 12 channel. Okay, so the question is also posted there. Okay, and let's work on this. Think about it. Okay, find your teammates, and this should be relatively easy. So you get only 5 minutes to think about it. Okay, so I see Guan Yu has already suggested this. So Bob, the user. So Bob's computer, it might be a laptop, right? So it's a lot of times you carry your laptop to school and you're moving from classroom to classroom. How would the receiver's mail server know where you are, right? Your IP address is here in this classroom versus another classroom might be different. Okay, yeah, that's a very good reason because Bob might not be always online, and also the IP address can be changing. So team 1, Liangxin, let's see. We think we want to combine SMTP, DNS, and HTTP together. SMTP we will use to send message. Okay. Server low balance. Okay, so hey, Liangxin, you might want to think again what the question was. Okay, We haven't actually talked about DNS. Yeah, no worry, we have 2 more minutes. Yeah. So Bob might not be always on the internet. Alice might not be either, but when Alice is sending email, Alice is on the internet. Okay. And the mail servers are on the internet, whether it's the sending side or receiving side. Yeah, so in a way, when Alice is sending an email, sending server is there, receiving server is also there, but Bob might not be there. Okay, so I guess that's what Guan Yu wants to say. So that's why SMTP cannot work all the way through to Bob. So Ziwei is saying Alice might need to be online until Bob is online. Yeah, so this is trying to prove by contradiction, I guess. Wei Ze is saying this. Right? In order for Alice's email to reach Bob straight, right, Bob needs to be online. But it's not exactly possible. Therefore, SMTP cannot work all the way through to Bob. Yeah, if we rely on SMTP to reach Bob, yeah, both of them need to be online, and where Bob is needs to be known to the receiving mail server, isn't it? And Jason is saying Bob might be online on some devices, hence the IP address might be different as it is on different domains. Yeah, so Bob is on and off and changing places. So that is saying that the receiving server might have a hard time tracking Bob. One can actually program into SMTP such that the receiving mail server tracks exactly Bob's IP address. But you see that this is probably a little bit tedious. So it's technically a little bit challenging. So I guess Jason is saying that one can potentially design SMTP such that we reach out all the way to Bob by tracking Bob's IP address. Or tracking whether Bob is online. That's what Wei Ze was suggesting. Okay, good point. Yeah, I see that you guys are getting the point. So the reason that the receiver, Bob, is fetching more actively when he needs to read these emails, when he wants to read these emails, and because that's an action triggered by the user, him herself. Unlike SMTP, which is to push emails all around on the internet. So the functionality is also a little bit different. If we want to put that functionality into SMTP, that makes SMTP also a complicated protocol. So that's why SMTP there stop right at the receiving mail server. And the part about intended receiver of the email trying to read emails will just have this email access protocol that allows Bob to do that. So clean cut of the functionalities between pushing email out versus fetching email. All right, very good. And let's come back to the topic here. So we are not quite yet done with the communication model, the architecture of email. You see that the architecture is already different from HTTP, right? There are clients and servers, but in email, we have actually 2 level of servers. Architecture different. All right. So it's also a TCP connection. Now let's go through a demo video so that you get to see a little bit more in more detail how the email protocol works. Okay.
This is a very simple SMTP exchange. Let me explain the notation. S being the server, C here being the client. Now in SMTP, this is the receiving mail server, and this is the sending mail server. Once the TCP connection is established, the receiving side identifies itself first. 220 hamburger IDU, status code, status phrase. Client here then would in turn tries to identify itself as well. Purpose.friends, that's the identity. And hello here is the command to allow the server to know who the client is. And then server, status code 250, everything is fine. Hello, purpose.friends. In the beginning from here, we start to see control message exchange. Client here needs to specify who the sender is and who the recipient is. So mail sender is Alice, and mail recipient is Bob. So all capital here, mail from. All capital here, receive to. Okay, are special commands as well, just like the hello. So whatever comes after the columns are the mailer and the recipient. So server again are just saying, okay, good, I got it, 250. And from here on, this is the actual data exchange. Data, once again, command. Email starts from here. Do you like ketchup? How about pickles? And it ends with a single line that has only a period. So the actual email message is only this short, 2 lines. Last is here, just to close. Okay, server will say, message accepted, everything is fine. Client then issue yet another command to quit the session. Server says, all right, goodbye. Very simple. To set up connection, to do the email exchange, and to close the connection. In the email exchange, there's the control message part and then the actual data part. That is an SMTP message exchange among the client and servers. Let's try now to telnet to an actual mail server at port 25 and see what the server would send back to us. And then we could try to type in some of these comments out and see how the server responds. So let's go to the demo mode. Now let's try telnet to a mail server at port 25. Telnet, which mail server? Actually Googled up Gmail's mail server. The name is this, SMTP, how appropriate, gmail.com, 425. There we go. IP address being 64 something something. And this is a message coming from the server, 220. Alright, so SMTP, gmail.com there is identifying itself. And then ESMTP, okay, it's saying more. I'm not quite sure what this is. Right, so E must be something and then SMTP. So this might be a special variation of SMTP, maybe the encrypted version, I'm guessing. So let's try typing up some of the comments. For example, hello, and coming from us, .edu.tw. How about that? Great, seems to be working. 250. So the server is saying, ooh, at your service. That's really polite. Alright. Then let's try the next comment we saw earlier, mail to. And let's have Gmail sending to pollys email address. How about that? What is this? 530 5.7.0 must issue a start TLS comment first. So yeah, it does look like it's trying to establish an encrypted connection. So TLS, if you recall, is what? Transport layer security support. So I'm guessing this is probably the credential, the public key. So I'm supposed to send back the share secret key with the public key as the key to encrypt. Oh, but I don't know how to do that. So yeah, let me try it again then. Playing dumb here. Poly Huang at ntu.edu.tw. Let's see. No, it's not accepting it. So I have to, yeah. So maybe recipient from Yeah, Polly's Gmail address. How about that? No, it keeps bugging me saying, okay, let's do start TLS. So that's issue this command, start TLS, and see, start TLS. Oh, cool, it's accepting. That's nice. Ready to start TLS. All right, so then I suppose I need to send back the, I'm already out. So it seems that the establishment process there also has a time limitation. Otherwise, yes, and hacker might be able to hijack something that you have done in the middle. Interesting. So hey, I got kicked out. So Gmail is a secure email service. Email messages are encrypted. Nice. Good to know. And so that was a demo of trying to Telnet to a mail server, actual mail server. You could also try this yourself, maybe from the workstation. Okay.
All right. And you know what? There are a few more teams. Type up your solutions for quiz 12. You see, Howard here is saying that, hey, Bob can be on and off the internet. Bob can also have multiple devices connected to the internet, right? How would the receiving server know which user agent to push, or pushing to both user agents? Okay, this is yet another good reason to separate accessing email from pushing emails out, right? Yun Tong had a good point, right? Because the functionality of reading email and pushing email out are just very different, the usage very different. Bob will only check when he is online or he feels like reading the emails. Okay, it's not like Bob can stay there all the time. And you see, Youyu was very, very clear saying this. If you recall SMTP, it's using TCP, establishing a TCP connection before sending the email. So hey, how do we create a TCP connection? The sender and the receiver, or the client, the server side, needs to be online in order to maintain that TCP connection, right? So if Bob might be there, might not be there, how do you keep that connection open so that I can send emails? Exactly. Okay. So Bob, you don't, not being predictable. Okay. The end receiver of an email, it's hard to predict when he or she is going to be online using the user agent. So mail access protocol is necessary to cut the different functionalities. Okay, separate the different functionalities. All right, so that takes us to the second part of email. Let's go over the message formats of sending emails first, and then we'll see how the email access protocol works. So POP3, IMAP. Okay.
And just a few words about SMTP at the end. Once it sets up a TCP connection, the client there can use the connection to send multiple emails. So it runs just like the persistent connection we see in HTTP. SMTP requires text in ASCII code, very strict. And SMTP uses just a single dot in the last line, okay, to determine whether it's the end of the message. Now, if we compare SMTP to HTTP a bit more, they differ in multiple ways, but they are also similar in another way. So this is the first thing they're different. Yeah, the service sort of direction. HTTP is actually to pull objects down, but SMTP is to push objects out. Now, object here I meant email. They are similar in this way. Comments, responses, all these messages are in ASCII text format. But HTTP and SMTP are also slightly different in this way. Each object is encapsulated in a response message. So HTTP server there sends one object at a time, one object per message. But SMTP can send multiple objects in one message. That message is just having multiple parts. So for emails, that comes with an attachment, like a big PDF file after, here is the attachment, if there's anything wrong, contact me. So email, the original text at the beginning, and then additional attachments. They can be sent as a multi-part message. So multiple objects in one message versus HTTP. One object, one message. Mail message format. So there's yet another protocol that defines how the email messages should look like. So this will be the data part of the SMTP protocol message exchange. If you recall in the example earlier, there's the opening phase, some control messages being sent, and then comes the actual data before closing. So the mail messages here we're talking about is the content being sent in the data phase. All right, so these messages are not control messages for SMTP. So they are not SMTP. The mail message format is actually defined in another RFC. It's another protocol. So in that protocol, it defines the mail message format. There are two parts only. The header containing a number of header lines, specifying who the receiver is, who the sender is, and what is the subject of the communication. In the body, very simple, just the content of the communication. So note again that I try to clarify. In SMTP, you see mail from. So this sounds like, following this command, you also tell who the sender is. Rec2, after the column, you give the recipient's email address. So it sounds a little bit like the to line in the header line and the from line in the header line, but they are actually completely different things. These go in the data part, while these go earlier, setting up a connection ready for data exchange. And then we'll switch gear just a little bit and talk about the last part of email application. So we've talked about the flow of sending an email all the way from Alice to Bob, right? So mail access protocol runs here. Okay, so it's this part of the entire flow. SMTP that we talked about earlier only covers email exchange to the receiver's mail server. In between the receiver's mail server and the actual receiver, it's this protocol that's controlling. So what it does is to allow the receiver to retrieve email from its local server. There are three very popular mail access protocol, POP3, Post Office Protocol, IMAP, Internet Mail Access Protocol, and HTTP. These two, you can see that they are more specifically defined for the purpose, allowing a receiver to retrieve email. The functionality is also similar. First, the receiver needs to authenticate itself, authorize itself, and then begin downloading emails. IMAP being a slightly newer version, it includes a number of other features, including, for example, we could store the email messages in a more structural way, for example, creating folders and putting certain emails in certain folders. Right. HTTP, however, is special. It's quite fashionable these days. Some of the mail service providers are asking us to use a web browser as the user agent. And then the email server there is essentially also a web server, so that it runs HTTP in the middle and treating each email as a web object. So fetching an email, fetching a web object. Okay, it's the same thing except that the content is more specifically being emails. And let's take a closer look at how POP3 works. Okay, the exchanges between the client and the server. The notation is very similar to the exchange we saw earlier in SMTP. S being the server, client is C. So there's an authorization phase and then the actual transaction phase. So authorization phase you see here, the client comments very typically being declaring the username and declaring the password. So you see here in the authorization phase, server says, okay, I'm ready. Client says, I'm user Bob. So the username there is Bob. Password, being hungry. All right. And server responses with either okay or negative error. It's even more simpler. All right. So okay here, okay here, okay here. Maybe with the phrase after that. And in transaction phase, this is where the emails are actually retrieved. So clients sometimes say this, list. So this is to ask the servers to tell back the list of emails there are. So this is more the index of the emails, and a lot of times just containing the file size and maybe the subject line. Right? It's only until the client begin issuing comment like this, RETR. So this is for retrieving messages. So RETR1 indicates that it's retrieving this email. So this is the index of the email, the size of the email, and there could be other information. Then the server sends back the actual content of the first email, and again ends with a period, and only one period in the whole sentence. Right? The client can actually delete an email that has already been read, or in case it's a spam. All right, so DELE, very intuitive, being the delete. Quit, also intuitive, being quitting the session. All right, so retrieve an email, server sends an email, client delete an email, retrieve another email, server sends another email, and client deletes yet another email. Q and then plus OK, server says goodbye. So that's an example of POP3 exchange.
All right, so that's all the video content we have today. Yeah, I see that many more of the teams type up the solutions. Yeah, Bob may have to stay all the way online, always online, in order for SMTP to work, if SMTP needs to work all the way, right, to the receiving user. Good, so very good. So maybe we could use the remaining time here, to go over the important points about exam 1. All right, we have only 5 minutes. Let me see if I can go through all these. Okay, so the exam is going to be on March 23rd, next Wednesday, 10:20 to 12:10. And you do want to arrive earlier, okay, 10 to 20 minutes earlier, so that there'll be enough time for Poly to check your student ID. So the reason that we do need you to set up a camera, software cost connection aboard. Software cost connection aboard. Hey, this is a very general error. So I guess, by the way, Wei Yuan, how about Googling this up? I find Google very, very powerful. Okay, sometimes when I'm playing with my own machines, and I got these weird debugging messages, and I just Google it, and I find that people asking the same thing on Stack Overflow. Okay, network error, software cost connection aboard. Yeah, I think something is going on there, so your connection is disconnected somehow. So let me go over the second point. Okay, the exam will be served as a Google form. To get a sense, okay, how to work on the exams, definitely try the old exam forms from 2020 fall or 2021 spring. Okay, and you do need to email to a Gmail account to fill in the Google form. So make sure that you log into your Gmail account before working on the Google form. So let's see, the exams, the Google form exams can be found here from the exams link. Okay, once you clicking, definitely read through all the descriptions here. Okay, I think at some point here. Okay, please do walk through these sample exams. And these exams are in the Google Forms. So for example, fall 2021, exam number 1, if you click in, you see, voila, it's a Google form. And you start by typing up your email. So you definitely want to make sure that you type, there's no typo here, because once you submit, Google Form will send your form back to your email so you can confirm what's going on. And from that email, you can click, so there's a link, so you can click back to the form that you have been working on. Okay, so that's how you get back to the form you are working on. All right, so that's why during the exam, you definitely want to submit and make sure that you get that email so that you can come back to work on the same form. So type up your name here, and then type up your student ID here. So let Polly do this. So this one doesn't need to be a Gmail account, I think. But you need to log in as a Gmail user. So I actually log in using my own Gmail. Or you can use NTU's Gmail, I suppose. Polly Huang here. Student ID B something something something. So I'm just typing something a bit random here, and you can hit next. That will take you to the next phase, which are where the problems are. Okay, so this is I think one of the old problem set, and I think exam 1 will be very similar to your exam 1. So this is fall 21. So this is last semester's exam. So if you work on this and click, for example, if you think B is right, answering the exam questions will be something like this. But of course, you want to read the questions in detail. Consider the three figures below that highlight different parts of the mini internet. You've seen several times in class, remember in chapter 1, right? We kind of see this picture a lot. And A has this part of the mini internet highlighted, right? Mostly cable and base station. B is showing I think these are the end systems, right? So the desktops, the laptops, the smartphones. And figure C is the routers, okay, in the core of the internet. So let's see, problem 1-1, it's asking which figure highlights the access link. Okay, so Polly would actually click A here. Which figure highlights the end system? I think it's B. And which figure highlights the routers? That will be the C. So that completes problem 1. And then there's problem 2, problem 3. If you read on, usually the problems get more complicated and then taking more time to answer. And you can see sometimes the questions can be a little bit long. And I think problem 5 here is asking you to calculate the response time, I think. Oh, no. This is to find out what is the best packet size. Okay, interesting question. Interesting problem to work on. All right, so definitely work on these and see how much time it takes you to go through the problems. Okay. So problem 6, you see also, hey, for problem 6, you will need to log on to the PA servers to do the pinging and find out the delay. So logging to the PA workstation using your exam account. So these exam accounts will be available next week, next Tuesday. And then you can try logging on before the exam. Okay. So you will need log on to the PA workstation and try pinging this machine, www.amazon.com, and find out, maybe what's the delay, round trip delay, things like that. And this is the exact command you need to type on command line to ping a particular machine. Okay. So this is like exercising question. So when you're done, click done. Okay, something like that. But even if you click done, but you did not do anything there on the workstation, Polly would check whether there is indeed a amazon-us.txt created. Okay, so that's a proof of you've done this. Okay, so there'll be some problems more like that. Okay, and 7, 8, as I said earlier, that the exam is very long. At the beginning of the semester, the exams are very long. For most of you, I think for all of you, you won't be able to complete all the problems. And this is by design. So that you will be busy working on answering these problems for yourself instead of having time to help other people out, other classmates out. Okay, you see, very long. And when you're done, click submit. But sometimes if your network is not exactly stable and you hit submit too late, or you hit submit a little bit too late after the deadline, then there might be some issues. So you do want to submit every now and then. So for example, in the midpoint of the exam, Polly will say, hey, this is already midpoint, you might want to submit. Then you scroll all the way down to submit, okay? And then you come back. Once you submit, let me see how it looks like. It will be like this. So you can click back in to edit your response. So most of the time like this. And if you click back and your browser is not showing edit your response, then hey, make sure that you go to your email reader and find out what is the link provided in the email that's generated from Google form. But you see that it would take some time for Google form to send that email as well. Okay, so make sure that you have a stable network connection there. during the entire duration of the exam. Okay, so if I do this and hit submit again, so usually it doesn't take all that much time. So do not worry that clicking submit, then you cannot submit the new version of the exam, new version of your answer anymore. You can always come back and work on it until the deadline. All right, good. So hey, this is already 2:14. So how about we come back to tomorrow morning and start by talking about point number 3. Okay, and let's go through all the 8 points before we start lecture tomorrow. All right. So between now and then, go on and work on these old exams in Google form so you get a better sense. Good? Good. All right, so I see you tomorrow. Okay, bye. Bye, guys. Yeah, wait, let's see what this message might mean. Okay, so let's Google it. Software call. Oh, okay, so this is a party. This is a party message. 想想肯定是。老师。Fatal error. So maybe I can click here. Okay, bye. So tomorrow, definitely try to have your camera and the laptop and the environment you want to do the exam. So you have a peace of mind if you manage to test everything out. I guess this is the message you got, right, Wei Yuan? Can trigger this error if party has given up on the machine at the other end of the connection. Yeah, so this is usually because the server is not reachable. Okay, let me see if so it depends on who you are connecting to. Okay, so let's see if I can connect to I can connect to the PA server fine. Yeah, but sometimes the delay might be a little bit too long. Good luck for the visit to the dentist. Yeah, I think it's probably just the usual checkup because later this afternoon I'm gonna also have my teeth cleaned. Just yeah. Okay, hey, dental health very important. So good for Wei Yuan. Okay, bye, Ziwei. Okay, let's go through how you take the exam tomorrow morning before the lectures. And tomorrow we're gonna talk about DNS, very interesting, and P2P, even more interesting. Okay, go. Okay, let me end the stream.